All right, guys. So, welcome to part two of day number 9. Again, a little bit of a longer day. Day 8 and day 9 are definitely on the longer side, but I wanted to make sure I broke these up into two parts. That way, you guys could digest them a little bit easier. And so, part two of this day is really just going to be dealing with remaining, if I can remember how to spell, remaining theorems, particularly involving angle size as well as side size and exterior angles. So remaining theorems are going to mostly deal with angle and side size as well as exterior angles. And for example, we can see right here, exterior angle inequality theorem. It comes back. The inequality theorem part comes back. Now the exterior angle, we talked about that a while back. So if an angle is an exterior angle, then its measure is going to be greater than the measure of either of its corresponding remote interior angles. Now, if you remember, we said that to get an exterior angle, it's going to equal two angles added together, and those angles are remote interior. So to get an exterior angle, it's going to equal two remote interior angles added together. And let's see what that looks like here. So, for example, here is 7. Angle 7, that is an exterior angle. Well, let's look at this little triangle that's beside it. What would be its remote interior angles? So 7 would be equal to, 1 plus 3? And actually, I think there's something else that would be equal to. Angle 7 could equal, isn't this whole thing a triangle? Check that out. So what would be the remote interior angles? Well, it wouldn't be 2. That's right beside it. So it'd be 6. Angle 6 plus, it'd be angle U. But U split up between 3 and 5, so it'd be angle 6 plus angle 3 plus angle 5. So we see that using this strategy up here, that's an interior angle, and these two combined make an interior angle. Okay? So what would 7 be greater than? Well, wouldn't it be greater than all of these that have to add up to be it? So it's greater than angle 1. It's greater than angle 3. It's greater than angle 5. And it's greater than angle 6. Those are all remote interior angles. Heck, angle 5 isn't even, and angle 3 aren't even interior angles. They have to add together to make one. So what I want you guys to do, I want you guys to try this for angle 1, which will be exterior based off this triangle, and angle 4, which would be exterior based off triangle UTW. And then for this one, it would be UWV. So if you're a little confused as to which triangle to look at for this to be exterior and for this to be exterior, there you go. So go ahead and try these, guys. Give me your best shot. You can go ahead and pause the video. All right. So we know angle 1, if it's the exterior of this triangle, it's going to need 5 plus 6 to add up to equal it, which means angle 1 is obviously going to be greater than angle 5 and angle 6. Same thing for angle 4. We know that we need angle 2 plus angle 3, the two remote interior angles, to add up to be the exterior, which means that those two remote interior are going to be smaller than the exterior angle 4 that they add up to equal. Yep. So I promise the rest of these are not going to be that much work. That one required a little bit more work. Let's check out this next one. This next one is what I like to call, I call this common sense. We're not going to spend a whole lot of time on this. Big thing here to recognize is if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. All that's saying is the bigger the side, the bigger the angle. So let's list from largest angle to smallest. Let's see how we would label this. So remember, the angle opens up and creates the side opposite of it. So angle C is creating 50. Oh, and 50 is the biggest. So angle C definitely goes first. Angle A opens up to 44. It creates 44, which I'm pretty sure is the second largest side, because angle B then opens up. So it's definitely the smallest angle because it opens up and only creates a side that is 29 feet long. So that would be from largest to smallest. How about this last one on the page down here? So a town park is triangular. Hey, they got a park like this up in Lexington, Ashland Park. So it is triangular. Now, a landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Okay, so remember, the largest angle is going to create the largest side. So where's our largest side at? Ooh, definitely here, 175, and that's along Hollingswood Road. What angle creates that? Well, pretty sure it's going to be this angle right here. And so which two streets form the corner with the largest angle? So if our angle is right here, looks like that is MLK Boulevard, RIP, and Valley Road. Yep, so remember, the biggest angle opens up to create the biggest side. So these two streets are what create that angle. On to the last page. So we're going to finish on this last page with some, in my opinion, fairly basic ideas, as well as some review. So this is page 4. So of course, a theorem, if we were talking about sides earlier, then it would make sense that if one angle of a triangle has a greater measure, then the side opposite is the greater angle. So again, we know angle 70, that's going to create BA, which looks like it's going to be longer than the other two sides because our other sides are 50 and 60. So we would say that our longest side would be AB, or BA, because 70 degrees creates that. Our shortest side is created by angle 50, angle B, which goes to, looks like, AC. So that is a helpful reminder, guys. The angle creates the opposite side. That's what it's connected to. It opens up to the opposite side. Okay. Our last real problem that's going to require some algebra here. We're going to find the value of n. So first thing, what I like to do, guys, I like to box what I'm going to need to be doing. So I need to find the value of n. Then I'm going to list the sides from shortest to longest. Okay, so two things here. Find n, and by finding n, that's going to let me then figure out what the angles of these triangles are. And once I know what the angles of these triangles are, I can match them to their sides. So let's call, I'm just going to call this Q, call this P, and call this R based off R3 here. So P is 9n plus 29. Q is 93 minus 5n. That's a weird one. And then R is 10n plus 2. And here's the thing. We may not know what these angles are, but what do we know all three of these angles add up to be? That's right. All three of these add up to be 180. So it's going to be 9n plus 29 plus 93 minus 5n plus 10n plus 2. And guys, try and reduce this as in one step as you can. 9n, negative 5n, and 10n. Those all go together. 29, 93, and 2 all go together. So whenever you combine all those together, I believe you get 4 plus 10 would be 14n. And then 29 plus 93 plus 2, that's going to give you 124. And so once you've combined all these together to create this is an equation that I know we can solve. Subtract 124 over, and then divide by 14. So subtract that over, divide by 14. You get n equals 4. So hey, there's the first thing we needed to do. We found the value of n. Now, so we've done that. I'm going to highlight it just to show you that we've done it. Whatever you can do, guys, to make sure you know that you have completed everything, I would strongly encourage it. Now, we're going to take 4 and plug that back in to our 3 sides to find out what we ended up getting. So take 4, plug it into this side, and I believe when you do that, you get 65 degrees. 4 times 10 is 40 plus 2, you get 42 degrees. And then 4 times negative 5 is negative 20. 93 minus 20 would be 73 degrees. So what would we say as far as our sides are concerned? So from the shortest sides to longest, be careful here. Be careful. Because we know that the angles go to the opposite side. So what's our biggest angle? 73, so that's going to go last. Well, what's our shortest angle? 42. So angle R projects to, looks like PQ is going to be our shortest. Yep. Followed by, we got 65 degrees. That angle opens up to QR. And then finally, 73 degrees opens up to PR. So that would be the sides from shortest to longest. And then finally, we just got a few quick reviews down here. Not really any math, just some friendly reminders. Just a review of a few ideas. When it comes to isosceles triangles, we know that if their sides are the same, that must also mean, what about the angles that create those sides? Angles are the same. So if sides are same, angles are too. The angles that create those sides. Next, scaling triangle theorem. If a triangle is scaling, then the shortest side is opposite the smallest angle, and the longest side is opposite the largest angle. Well, that's just kind of common sense. We've talked about that. So what would your largest angle be in this problem? Let's label this B, A, and C. And what would that mean for the largest side? So it looks like our largest angle is going to be the obtuse angle here, A, and it's opening up to side BC. And then finally, an equilateral triangle theorem, all this is saying is a triangle is equilateral if and only if it's also equiangular. That means same angles create same sides. Just like we talked about up here, except with an equilateral, it is all angles, all three. So 60, 60, 60, they all create, because they're equiangular, that means they're also equilateral, same sides. Yep. So thank you guys. Don't forget we got our test this Thursday. If you have any questions, you can contact me through email. We can set up a Google Meet, remind, and just make sure we're working on our delta. Don't forget about our multiple choice Google form for day 8, the multiple choice for day 8, and then test in a couple days, guys, on Thursday. Have a great day. Enjoy the snow.